So welcome to this week's weekly workshop. The point of discussion this week is network services. This week we're going to talk about network services, do a little bit of hands-on, probably not very much, and the hands-on stuff we're going to do a lot more hands-on next week. So this week we're going to finish up the discussion of networking, talking about network services. Next week we're going to do some very introductory hands-on to introduce people to Kali Linux, and that's something that I probably should have done earlier. I certainly should have done earlier in these series of weekly workshops, but I didn't, and so now I want to go back and do it, and I want to do it before the holidays with the expectation that there may be teachers who are starting new classes after the holidays, and so they may want to have access to this introductory Linux introductory content, so they can use some hands-on exercises that I'm going to use to use with their class and teach them some of these basic intro to command line and that kind of stuff in Linux. Okay, so weekly workshop, cyber education topics, Tuesdays, 1 p.m. Most weeks, recorded and shared at our webpage. And then if there's a particular topic you want to see, you should send an email to either directly to me or to contact@virginiacyberrange.org, and we will add that to the list of stuff. Lots of different topics we could talk about. We're going to finish up this semester with one more discussion next week on intro to Linux, and then after that, we're going to take a break over the holidays, start up after the holidays, and not quite sure we're going to do it right after the holidays, but eventually we're going to get into capture the flag competitions and some tools that you can use to solve CTF problems and that kind of stuff, but maybe not right away after the break. Okay, some recent news. Marriott hotel chain was hacked, and this is the hack dates back to 2014. So this is a Reuters news story, and this is something that if you didn't see this over the weekend, so today is the 4th of December, and if you didn't see this over the weekend, then you're just not paying attention, because this has been all over the news. News story released on, pretty sure it was last Friday, and that's kind of a popular time to release bad news because a lot of people don't notice it, and by the time they get back to their news on Monday, then the cycle has passed the story. In this case, this has been news since the end of last week, and it continues to be news. The major headline is Marriott hacked, but if you delve into it a little bit, you'll see that really it wasn't Marriott that was hacked, it was Starwood that was hacked. So Starwood is a hotel chain, series of different hotel chains, includes Sheraton, Ritz-Carlton, some others, and their customer database, their loyalty program database, was hacked back in 2014, and they just discovered this fairly recently, and so it wasn't actually Marriott that was hacked. So if you're a Marriott, and so far the evidence suggests that Marriott itself, the Marriott rewards program itself, was not compromised. So, and those rewards programs merged back in 2017 or 2018, where the Starwood points rolled over into Marriott, but still it appears so far that the Marriott loyalty program was not compromised. So this is really a Starwood thing, and Starwood was acquired by Marriott in 2016. So the fact that this hack started back in 2014, it predated Marriott acquiring it, and certainly at some level there's some due diligence that should have been taken to make sure that Starwood wasn't compromised. Certainly Marriott did something to try to confirm that, but maybe not quite enough, because the fact of the matter is that Starwood's loyalty program was compromised before Marriott acquired them, and the data that was likely compromised is listed here in the last bullet. So could include account info, username / password, phone numbers, passport numbers, email addresses, and even payment card info. And could include, basically, I think what that means is that likely includes, right? So sometimes it's hard to tell exactly what the bad guys got, especially when the hack dates back 4 years. But I think what Marriott/Starwood can say is that this is the data that was resident in the database that was compromised. So it's pretty likely that whoever hacked Starwood got access to all this data and the payment card info. In the cases where the people allowed Starwood to store their payment card information. So that's one sort of suggestion I'll make. On the next slide, I'm going to talk about some steps that you can take if you think you might have been compromised in this particular hack. If your data, if you were a Starwood person prior to the merger, then it's likely that your information is compromised. And so I'm going to suggest that you take some actions. The first thing I would suggest that you do, and this is not related directly to Marriott, but I suggest that you don't let online companies, whether you're shopping or reserving hotel rooms or whatever, don't let them store your payment card information on their website or in their database. And they have to ask you before they do that if they're complying with the payment card industry security standards. So often when you put in your payment card information, there'll be a checkbox that may be checked by default, and then it'll ask, do you want us to store your credit card information? And if you check it, basically what they do is I'm sure they encrypt your data and throw it in a database somewhere. But if that database is compromised and the hackers are able to get the encryption keys, then they have your credit card information, and that's generally bad, right? So if you don't allow companies or hotel chains to store your credit card information, then after they use it for that particular transaction, then they delete the credit card information, and it's not exposed. At least, there are certainly ways that it could be exposed, but it's less of a threat because what the company should not do is it should not store it anywhere on their end. Of course, next time you go to that website and try to, for example, reserve a room at Marriott.com, then they're going to ask for your credit card number again because they didn't store it. So it makes it a little bit less convenient, but I would say. So for those just joining us, weekly workshop. This is the recent news. Marriott was hacked, and I'll let you review the bullets on this slide. You might want to pause it, but I've started the recording late, and so I'm not going to go through all this again. What I was saying was that if you make a payment to a hotel chain or to buy something over the internet, when you put in your credit card information, there's often a radio button that you can click that asks whether you want to store that. Sorry, I was reading another chat. If you want to store that credit card information with the website, and I would recommend you not do that because then it ends up in a database somewhere, and if that database is compromised, then your payment card information could be breached. If you don't allow the organization to store your credit card number, then they use it for the transaction, then they delete it, or that's what they're supposed to do according to PCI DSS, which is the payment card industry digital security standard. And so again, I suggest that you don't allow websites to store your credit card information. Again, a little less convenience, but a little bit more security. So the question then may come up: what do you do if you are a Starwood preferred or a Marriott.com person, and you could have been subject to this breach? So I'm a big Marriott person. I stay at Marriott's all the time. I've been staying at Marriott's for a long time. I also had a Starwood account previous to my Marriott, previous to the merger. So it's likely that my data was rolled up in this breach. So here are things that you can and should do, or even things that you might consider doing. And we'll talk a little bit about the pros and cons of some of these as we go through it. First thing to do is change your Marriott.com password and/or your Starwood. It's the loyalty program is called SPG, which is Starwood Preferred Guest. Change your accounts on those websites. I would say change them immediately. Of course, this data has been accessible for 4 years, so you can't change it 4 years ago, but you can change it now to prevent future unauthorized access to those accounts. Second bullet there, don't reuse passwords, right? So if your password in your SPG account was compromised, and if you use that password elsewhere, then people are going to try to use that password to log into other systems using your email address. And that's a very common kind of a hack these days. Most of these accounts use your email address as the username. Back in the old days, you used to be able to come up with a username, but now the common practice is you create an account for a website and they're going to use your email address as the username. And so now if a hacker gets access to that data, if they're able to compromise your account information, username and password, they can try to use that username and password against all kinds of different websites. And if you're a reuser of passwords, then you could be in trouble. So never reuse passwords. Use long and or complex passwords. So longer is generally better. In fact, new NIST guidance says that passphrases are best as long as they're more than 20 characters. So a passphrase is like a sentence, right? So, the quick brown fox jumped over the lazy dog, that could be a password. Maybe you don't use that one because it's a sort of commonly used sentence, or at least used to be in typing class. But use a sentence that you can easily remember rather than some random string of letters, numbers, bells, whistles, etc. But the bottom line is longer is better. Longer is better. If you throw in special characters and uppercase, lowercase, that's gonna make it even better. But the NIST guidance is 20 characters is their recommendation. It'll take a long time for most organizations to catch up with that guidance, but that's the current guidance. I say longer and more complex passwords are harder to crack if they're stored properly. So what organizations should be doing is storing those passwords as hashed passwords. So the passwords should be salted and hashed and stored in the database. So if they're compromised, they're not easy to turn back into a password, and the more complex they are, the harder it is to take that compromised hash and turn it into a password. In the old days, lots of passwords are stored in plain text. That is extremely rare now, but that's still discovered once in a while. Somebody gets compromised and they discover that the passwords are stored in plain text. That's extremely rare these days. And of course, if the password is stored in plain text, doesn't matter how long it is. If it's compromised, it's compromised. Fourth bullet there, use a password manager. That helps with things like changing passwords. It helps with preventing password reuse. It helps with automatically creating long and or complex passwords. And I list some password managers here: LastPass, 1Password, KeePass, Dashlane. There are others. If you use a password manager, you can automate. You can have it select complicated passwords for you automatically. I'll just say I'm a LastPass user. It's very convenient. I can use it across devices. I don't own stock or anything. It's just the one that I chose, and I use it. I'm sure these others are just as good. LastPass, the thing that makes it extremely convenient is your passwords are all stored in the cloud. So if somebody were to get unauthorized access to your LastPass password, then they could get all your passwords. So what I do recommend is with any of these, use two-factor authentication. So my LastPass account has a password. I also have I have two-factor turned on, so it's going to ask me to plug in a key fob, a USB key fob, and if I lose my key fob, then I can recover the password using SMS text, I think. But use two-factor authentication so that you have to not only have the password, but also some second factor like your smartphone that accepts text messages or whatever. And maybe I'll talk about password managers in one of these sessions and why they're important and all the great features that you can get out of them. But until passwords go away, which I think isn't anytime soon, that's a great way to manage your passwords. Because if you start to look, I use a password manager. I've been using one for years, and you discover that you have hundreds of accounts, and it's hard to use a unique password everywhere when you have 200-300 accounts in different places. All right, fifth bullet there, use credit cards over debit cards for electronic transactions. Okay, why is that? That's less a security thing and more a liability thing. So if you use your debit card and you get skimmed somewhere, so somebody's able to get your credit card info and your PIN, then they can use that PIN to pull money out of your bank account from an ATM, for example. With credit cards have much better customer liability protections, and it's just it's just the way it is, I guess I'll say. So under PCI DSS, credit card companies, if your credit card gets compromised, if somebody uses your credit card in an unauthorized way, you're only liable for $50 per purchase, and most credit cards will completely erase you'll have no liability. And you may have had this happen before. I've certainly had it happen before, more than once. You'll get a notification that your credit card was used somewhere where you are not, and the bank will ask you to authorize the transaction, and or you'll get a notification that somebody purchased something somewhere where you're not after the fact, and then the banks nowadays a lot of times will they're able to track potentially fraudulent transactions and let you know. Sometimes you don't know. So that leads into my next bullet. Oh no, not the next bullet, the bullet after that, where I say closely monitor credit card accounts. Look at your credit card amount every month and make sure that those purchases were purchases that you made. Sometimes hackers will try to slip things in. They'll make very low dollar purchases just to see if the credit card works and if nobody notices. So they'll make purchases for $1 or $2, and people generally sort of glaze over those on their credit card bill because it's only $1 or $2, but that's them testing to make sure that the credit card works, and then later they'll use it for some high dollar purchase. Again, credit cards have advantages over debit cards in that with a credit card, you're only liable to $50 per purchase, per fraudulent purchase, where with a debit card, you can be liable for the entire purchase amount. Can be. That's not to say that all banks do that, but you can be liable. And it's easier for somebody to clean out your bank account if they get access to your debit account information. Next bullet under the credit card over debit card is see if any of your online accounts have been compromised. So there's a website, Have I Been Pwned? I've spelled it out there. HaveIBeenPwned.com. That word PWNED, pwned, that's hacker slang for owned, which is hacker slang for hacked. Long story, I'm not going to tell it, but this website, what they do is this is sort of a good guy, right? White hat hacker who collects information from previous compromises, and he compiles it all under this Have I Been Pwned website, and you can go in there and you can type in your email address, and it'll give you the information about if and when that particular account has been owned anywhere. So if you type in, so I would say go there, type in your email address, and it'll either say you're good to go, or it'll list one or more websites and the username and password that were used on that website, if using that email address, if they were compromised, and you'd be surprised. I'd encourage you to take a look. And if you discover that one of your passwords was compromised, then I highly encourage you to make sure you're not using that password anywhere. Okay, last bullet, freeze your credit files with major credit bureaus. So I'm not telling you to do this. I'm telling you that this is something that some people encourage. If you certainly if you have good reason to believe that your credit card information has been compromised, or that somebody has tried to do some sort of has gotten access to important accounts like your bank or whatever, then freezing your credit files is definitely something that you can and should do. Some people sort of do this. They just do it. They freeze their credit accounts. And basically what happens is if your credit accounts are frozen, that if anybody tries to open a line of credit with your name, then that will be prevented. But you can freeze your credit files and unfreeze them through the credit bureaus. A lot of times it's free. Sometimes there's a small charge. The challenge here, and the reason I wouldn't say to just do it sort of across the board, is that sometimes it can be hard to unfreeze those credit files. And if you're trying to buy a car or buy a house and your credit accounts are frozen and you're having trouble unfreezing them, then that can cause you some serious problems, right? Some serious inconvenience, at least I'll say. And I've seen stories of people, you know, for weeks trying to get their credit unfrozen and having trouble because it's serious business, right? The credit bureau doesn't want to make a mistake, so they want to make darn sure that it's you asking to have the credit account unfrozen. Okay, so this is all advice that I would say is good for just about anybody in any situation, right? Change your passwords once in a while. Don't reuse them. Use long passwords. Use a password manager. Use credit cards over debit cards. Check once in a while to see if any online accounts have been compromised. Closely monitor your credit. And if you're really concerned, freeze your credit files. And so this is just kind of a reminder. And the Marriott breach was an opportunity to throw this out. Wow, I'm way over time already. All right, another funny story, not so funny maybe for some. Twitter user hacks 50,000 printers to tell people to subscribe to PewDiePie, which is a YouTube channel. Used to be the most popular YouTube channel, the one with the most followers. It was recently passed by somebody else, and so somebody started hacking printers and spitting out printed stuff. And hacking printers is pretty easy if your printer is connected to the open internet. And we've talked about this before. If you have a networked printer in your home, it's most likely protected by your wireless access point that does network address translation. If your printer is open on the open internet, which a lot of university printers are, some company printers are on the open internet, then you have to manage your printer much more closely. Configure firewall rules to prevent people from printing from outside the IP range of your organization, and that's something that your IT person should be responsible for doing. In this case, it's a simple little, cute encouragement to get subscribers for some YouTube channel. In the past, this exact hack has been used to send anti-Semitic flyers to printers across the U.S. It happened at Virginia Tech. So people can do things that are pretty nefarious. Okay, so I'm going to stop there. And let's talk about network services. You'll hear the word daemons associated with network services or servers, or demons. And that word, I'm not even sure where that word came from, but it's a word that has been used since the early days of networking to describe services running on a server. And we'll talk about what a service is coming up. So the learning objectives: describe the client-server networking model, understand basic network services such as the domain name service, web servers, file transfer protocol, and secure shell. So the client-server model is the primary model used throughout the internet, right? So servers offer services. And I give a couple of examples here. Websites using hypertext transfer protocol. So websites provide a service. They're listening for people to connect to them and pull data off the server. And that data, in the case of a web server, is in the form of a web page and then images and movie files and whatever else. A secure shell server provides SSH access. So the protocol is SSH, Secure Shell Protocol, and that gives you the console access to a server. And then email servers use a protocol called Simple Message Transfer Protocol, SMTP. That's how emails exchange information between each other. And it's this client-server model, right? So if you think of, we'll think of sort of the most common example, and that's websites. You have a web browser as a client application, and a web server is a server application. The web server runs on a computer. The computer is usually much more it's got a lot more RAM, a lot more processing power than your typical client machine. And that's because generally web servers expect to have lots of clients connecting to them and getting access to the resources. So it needs to have, more hard drive space, more RAM, more processing power, et cetera. So you have many clients connected to a single server. And so the expectation is that the server is going to be able to service all those requests. So the web browser connects to a web server, and the client is requesting data from that server, and that data is in the form of web pages and other content displayed on the web page. Email clients connect to email servers to grab your email. Okay, so similar idea, right? Your laptop reaches out to the email server once in a while, grabs the email, pulls it back to the client, and then you can read that email. It sort of muddies things now that lots of email clients exist in the web. So now you're using actually HTTP. You're using access to a web server to get access to your email, and you're using the email protocols to get access to the email at the same time. In the old days, we used clients like Outlook, right? So you had the Outlook email client, and what Outlook would do is reach out to the email server periodically, grab your emails, pull them back in, and then display them in that client software. Same when you send an email, you type an email, click the send button, and your client computer, which might be a laptop or a desktop or a phone these days, that client computer is going to reach out to the email server and give it that message to be sent on to somebody else. Okay, so clients and servers. This is just another sort of high-level picture. I wish I don't have I'm on an Apple, so I can't draw on the screen like I would like to be able to do. My Surface computer is back in Blacksburg. So here's a simple picture. You have multiple client machines on the other side of the internet, and then you have a server that's sitting in, usually a data center somewhere. So for example, www.vt.edu is a web server that is sitting in the Virginia Tech data center. So servers constantly listen for client requests. So the purpose of the server is to listen for people to connect to it and to grab web pages off of it and then display those web pages on the client machine. So the server is always listening for somebody to connect. And then clients request services over the internet from servers. So, and so this notion of the system always be listening for clients to connect, that's sort of the, that's the thing that makes systems vulnerable. If you have a system that's not listening for anybody to try to connect to it, then that system is generally going to be secure from compromise, at least compromise from an outside attacker. So the system could be compromised by you browsing to a malicious web page, or by you downloading, clicking on a link in an email that's malicious. But those things all require the user to take some action for that system to be compromised. If you just have a system sitting there that's not listening on any ports, then that system is pretty darn secure, right? So it's the fact that systems listen on ports for people to connect. That's what makes systems vulnerable, and so that's the whole basis for securing networks, is to make those systems less vulnerable. And there are different ways to do that we've discussed in the past, and we'll discuss more in the future. But this whole notion of client-server networking is it's important to understand in the context of how networks work. So the first service we'll talk about quickly is the domain name service, and I've talked about this before. In fact, I'm sure I talked about it last week. DNS is a distributed database that provides mappings from domain names to IP addresses, right? So the internet routes traffic based on IP addresses, and it does that extremely efficiently because the IP address, you see an IP address on this slide, 134.169.9.190. The way that's represented by the computer is digitally, and so it's a sequence of 32 zeros and or ones all chained together, and routers are able to very efficiently route packets using bitmaps based on that 32-bit IP address. And what the internet does not do is try to route traffic based on domain names like the one shown here, www.tu-bs.de. That's some German, I don't even know what that is. But you know, it'd be very inefficient for each router along a path to a website to have to like read that domain name and try to route based on domain name. I mean, that system would be very inefficient. So when the internet was designed, it was designed based on IP address. Each system was assigned an IP address. And back in the early days of the internet, when you had 10 or 20 systems attached, keeping track of which IP address belonged to which machine was very easy. As the internet quickly expanded in scope, it became extremely challenging to maintain this mapping of IP addresses, or to maintain the list of who owns what IP address. And so the domain name system was born. And originally it was a big text file that simply had a list of domains like vt.edu and a list of IP addresses like the one shown here. And the text file was emailed out to all hosts on the internet periodically, once a month maybe, because it didn't change very often. And when you needed to go to a web, or you know, this predates the web, but if you send an email to somebody, your system would look in that text file, find the domain find the IP address that goes with that domain, and then send the email through the email system to that you know, to that IP address. Nowadays there's billions of systems connected to the internet, you know, millions of domains. And so now there's this distributed database called the domain name system that manages all this. And so when your computer wants to go to a website, for example, if you're in California and you want to go to www.vt.edu, which is the Virginia Tech website, your computer would first make a query of the domain name system and ask for that particular IP address. And then the IP address would be sent back to your computer, and then your computer would route the request for a web page to that IP address. And hopefully we'll see that in action here in a minute. So it's hierarchical, right? So top level domains like .com, .edu, .org, .net, and then underneath those top level domains you have vt.edu, for example, and then underneath vt.edu you have things like www.vt.edu, and there's lots of other things under that too. You have it.vt.edu and security.vt.edu, that's the IT security office, etc. And DNS uses UDP port 53. So UDP, we talked about ports and protocols last week and the week before. UDP is the transport layer protocol that's being used here. It's user datagram protocol, unreliable, but for this purpose it works really well. It's very efficient. And so that's the port and the protocol that DNS uses. The web relies primarily on two protocols, HTTP/HTTPS, the protocol used by your browser to request web pages, and used by the web server to respond. So when I say HTTP, really I'm referring to both HTTP and HTTPS. And we know that the S makes your interaction with the web server secure, where HTTP is an unsecure interaction. And then HTML is the hypertext markup language, and that is just a markup language that is used by your browser to render the page in the on the screen, HTML. And these days, if you're gonna browse do an HTTPS site, and you were to look at that in a packet tracer like Wireshark, you wouldn't even be able to see the HTML because it would all be encrypted in the HTTPS connection. Web pages are simply a file or lots of files on a web server. So clients request files using HTTP. Browsers find the file on the hard drive and returns it using HTTP, right? So you know, in the early days of HTML, it was very simple. You had a file on a computer. Your web browser would go request a particular file. So if you were going to the Virginia Tech web page, for example, www.vt.edu, your web browser would request the file www.vt.edu/index.html. Index.html. That's the root web page in standard HTTP. And that was, again, that was a file sitting on the web server, sitting on the hard drive of the web server, or sitting in memory maybe. And the web server would simply return that file back to the web browser requesting it. And then inside that file, if you're familiar with HTML, you know that there's tags for different types of content that you might see in your HTML web page, things like images and video files and music and whatever. And so then what your web browser does is, as it interprets that HTML file, it goes out and grabs the image files, goes out and grabs the video files, goes out and grabs whatever else it has to grab in order to completely render that page in the web browser. So it's fairly complicated, seems really simple, but even that system is much more complicated than it was. And so again, here's the old way. Your browser does this HTTP GET, so it sends a GET request using the HTTP protocol to the web server. The web server grabs the file off the file system, so it grabs the HTML file off the file system. Web pages are just files. There's a little snippet of HTML, and then it returns the HTML page back to the requester, back to the browser requesting it. And I used a very simple web page here because most of this would be rendered solely based on the HTML file that it got back. There are some images down in the bottom. Those would be subsequent requests by the web browser to grab those files and render them on the web page. Okay, so next. This is how it works now, right? So this is the old days, very simple. Here's how most web servers work now. And I use Google as an example. Now you do an HTTP GET request and you get back the Google web page. And then when you type something into the Google bar there, you are sending an HTTP post request to the web server. The web server is gonna parse that request, then it's going to send a request to the database using something like SQL, Standard Query Language. Standard, is that what it is? Standard, I think so. Sends an SQL request to the database. The database is going to return a bunch of data, and then the file system is going to return an HTML template, and then the data is going to be rendered in the HTML template, and then that is all going to get put together automatically by the web server using some language like PHP or Windows Active Server Pages or JavaScript or whatever. And then that web page that's dynamically generated is going to get sent back to the web browser. So the whole system is much more complicated these days. And the fact that it's much more complicated makes it much more prone to being compromised, is the bottom line. Okay. So this is the little shot of the HTTP protocol, and here, if you go to the Wikipedia page, there's lots of data on HTTP. This is kind of what it looks like, right? So a user issues a URL, so you type something like this into your web browser, http://host. The port is going to be, you can put in a port if it's different than 80, but 80 is the standard port for HTTP. So generally, you don't have to put in a port number. Then /path/file, and that gets sent to the web server, and then the server is going to look for that file in the file system and it's going to send it back to the requester. So it's going to return this HTTP 1.1 200 OK. So that's a response message. The 200 OK from the server just means, yes, I have that file on my file system, and here I'm going to return it. You may be familiar with 403 response messages from servers. That's when the server does not have the file that you're requesting. So sometimes you get like this funny 403 error page. But that's basically how the World Wide Web works using HTTP. All right, so let's do a quick hands-on here. I'm going to jump into Wireshark, and I'm not going to. So you can do this in the Virginia Cyber Range. So there's two slides here that have similar content. One of them is something that you can do in the Virginia Cyber Range in the Cyber Basics environment. The next one you do outside the Cyber Range. The reason they're different is that Inside the cyber range, you can get access to dvwa.example.com, and that's in the Cyber Basics environment, and that is a web page that'll get returned to you inside the cyber range, and you'll be able to render it kind of like I do here over on the side. This next slide is for use outside the cyber range, and that is another web page that'll get rendered. If you go to acm.org from inside the cyber range, you're going to see a bunch of proxy traffic that sort of makes this request response more complicated than it needs to be. So if you're going to use this example in class and you're not doing it from within the cyber range, I encourage you to use this slide. Normally I would do all this in the cyber range. I would tell your students to log in, go to their Cyber Basics environment and do this hands-on in the range. I'm not going to do it right now because I'm on this not very good hotel Wi-Fi for the Zoom access. And if I add to that my cyber range access, it'll probably continue to work, but I'm not certain that it'll continue to work. So I don't want to kill my Zoom connection by logging into the cyber range. Probably wouldn't cause any problems, but in fact, I tried it before this, but I'm just not going to, whoops, I'm just not going to do it because I don't want to tempt fate. So I have Wireshark installed on my Mac. So I'm going to open up Wireshark. And I'm going to tell it to, let's see, I'm going to select, let me open up a browser too so I'm ready when the time comes. All right, so I'm going to start capturing on the interface, and now I'm going to go to www.acm.org. I get back a web page, and then I'm going to stop. So you'll see that in this, I opened up Wireshark and I started capturing traffic, and it captured a ton of traffic, and it's all UDP traffic, and that traffic is my WebEx connection, and it's all going over port 8801 on the server. So if I were to look at port 8801 traffic, I would see all this Zoom traffic, but also interspersed here is web page stuff. So I'm going to go to my display filter. What do I say to do on my slide? Let me make sure I'm following my slide. Wrong slide, sorry. Stop capture, go to top of capture, right click, follow TCP stream. Okay, so since I have all this other stuff in here, I'm gonna first do this. I'm gonna filter out. Surely that's not all the capture. Let's see here. Follow TCP stream. Oh yeah, I guess it is. Okay, so well, yeah, that's not all of it. So this is the TCP stream that has this interaction, and here's my GET request. So I right-clicked in the HTTP and I said follow TCP stream, and here's what I get. Here's the GET request I mentioned. So this is the web browser, and in this case it's going to Let's Encrypt. So it's not even going to ACM because ACM is using HTTPS, and it first goes to Let's Encrypt to get to check the certificate to make sure that it's a valid certificate. And then here's a response from the server, and the server is Nginx. It's responding with encrypted traffic. So ACM used to be non-encrypted, now it seems to be encrypted. So this is maybe not a great example. I'll come up with a better one, but not right now. So this is how you would inspect a, another thing I can do is I can say tcp.port. Clear my filter. If I say tcp.port equals 443, right? We know that 443 is HTTPS protocol. So I'm going to go up here near the top, and I'm going to right click and say follow TCP stream. Yeah, so my challenge here is I'm fighting with my Zoom traffic, and so if you were to do this on a system that's not in the middle of a in the middle of a WebEx or a Zoom thing, then you'd get better results. I'm not going to fight with it right now. You can do it in the Virginia Cyber Range in class, and you get a much cleaner result. I'm running out of time here, so I'm not going to jump in there. So we'll certainly do much more Wireshark at some point in the future, just not today. Okay, another protocol is file transfer protocol, used to transfer files between systems. Users can upload and download files from an FTP server. Used to be very widely used. Now it's less widely used because the basic FTP protocol is not secure. It's not encrypted in transit. So why is that important? That's a good discussion to have with students, right? The data is not encrypted in traffic. Who cares? Well, if the data is not encrypted in transit, then you can read the data from, if you're eavesdropping on somebody's FTP connection. And we're going to take a look at some FTP traffic here in a minute. FTP uses TCP ports 20 and 21, and Windows, Linux, and macOS all provide data of FTP clients. So if you knew the address to an FTP server, you could use FTP at the command line to connect and grab data off the FTP server. And there are fewer of those out there. There used to be lots of FTP servers, not so much anymore. So hands-on with Wireshark. So you might pause this slide for a minute. You can download this packet capture that contains an FTP exchange. So http://artifacts.virginiacyberrange.net/gencyber/ftp_attack.pcap. So this is not a space here. This is an underline underscore. Use this display filter to see all the FTP traffic. So if you're doing this in Wireshark, you want to say TCP port equals 20 or TCP port equals 21. And then I have two questions here. Who logged on to the FTP server? What files did they download? And this is a good exercise to use in class with your students. You can have the students, search through that FTP interaction and try to discover who logged in and what files were pulled off the system. So I already downloaded this. So if you missed that slide, you might rewind for a few seconds. Take a look at the slide. So if I go to my downloads, I already downloaded FTP. It's a PCAP file, so I have Wireshark installed on this Mac laptop. This is something that you can and should do in the Virginia Cyber Range. So if you do it in the Cyber Basics environment, you'd be doing it from a Kali Linux virtual machine, and Kali Linux has Wireshark installed by default. So here I double click the FTP attack.pcap file, and we're going to automatically open up Wireshark. And so, where's my slide? Go back to my slide quickly so I can show. Whoops, what am I doing here? That's giving me problems. Oh, come on. All right, I'm having problems here. I'm going to redo this. Move this out of the way. Okay, what I say in my slide now is TCP.port equals 20 or TCP.port equals 21. So in my Wireshark instance where I've opened this file, I'm going to type in TCP.port equals 20 or TCP.port equals 21. So Wireshark display filter, I'm looking for packets that are going to or from TCP port 20 or TCP port 21, and the green color of the filter bar tells me that my syntax is correct in my filter, which is helpful in Wireshark. When I do that, I filter out all of the interaction except for the TCP traffic, which runs on 2 ports, 20 and 21. So now what I'm going to do is I'm going to select one of these messages up here at the top, and I'm going to say follow TCP stream. And so we asked questions, right? We asked who logged into the FTP server and what files did they download. And so if we look at this TCP stream I just followed up at the top, this is the protocol, this is the FTP protocol exchange between the server, which is in blue, and the client, which is in red. So when the user first connects, here we did you'll see up at the top here. So last week we talked some about a three-way handshake between client and server. There's this SYN, ACK. Once that three-way handshake has caused a virtual connection between a web client or an FTP client and an FTP server, now the next message that you see is this response from the FTP server, a 220 response from the FTP server, and that basically that response says, it means yes, I'm an FTP server. Here's my version number, VSFTP 2.2.2, and now you can send me your username and I will connect you to our system. And again, I'm not doing this in real time. I'm looking at a PCAP file, so this is a recorded FTP exchange between a client and a server. So when I clicked follow TCP stream, I can see the server messages in blue, and I can see the client responses in red. And so the connection is made, the server responds to the client and says, I'm ready for you to send me your username. The FTP client sends the username, which in this case is anonymous. And then the server says, please give me your password. And the client sends back the password, h4x0r @evil.com, hexor@evil.com. It looks like it's an email address, but that's the password for anonymous. Login successful. So this is again a response from the server, and then the client can start. The client is going to do things like ask for lists of files and change directories into different directories and all this kind of stuff. So the question, the other question, so we know that the user is anonymous, right? And the other question is, what files did they download? And you could poke around in here for a while, and so you're not going to find the file in this particular exchange. Well, here is, here's one that's retrieve file.txt. Okay, so that's a file that got downloaded. So these are questions that in order to answer them, your students might have to poke around a little bit on the internet to figure out what the FTP protocol command is to download a file. And so retrieve is the FTP protocol command, RETR, all uppercase. And this file called file.txt was retrieved. And so that answers the other question. What files did they download? And the file that was downloaded was file.txt. That's all in this little exchange. And then there's a way that you can see exactly what was in that file. We're not going to do that right now because I'm already over time, and I'm going to stop. So that is sort of the quick overview of network services. Again, client-server model is important for students to understand. The fact that servers are listening for people to connect to them on the open internet is the thing that makes systems vulnerable. So, a system will get compromised, and then it could be a web server in an organization. It could be a some other kind of a server, a file server in the organization. And then what a hacker is going to try to do is expand their footprint from that particular system to other systems within the organization to get access to things that the organization doesn't want outsiders to have access to. Okay, again, I'm going to stop, and we will spend more time in the future diving into Wireshark. I don't want to spend a whole lot of time on it today. Gave you a little bit of a taste, and you can give that little bit of a taste perhaps to your students. after the break, we're gonna talk about. I'm not sure if we're gonna do this right away after the break, but after the break, we're gonna talk about capture the flag. When we do the capture the flag discussion, that'll be over several weeks, and we'll talk about different tools and techniques and things that you need to know in order to be successful to capture the flag. And Wireshark is an important part of that. And so we'll delve more deeply into Wireshark and how to analyze network traffic using this tool. Okay, so thanks for joining us, and we'll see everybody hopefully next week for our last weekly workshop of the semester. So thanks.